Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video we're going to talk about profit maximization and market performance for monopolies. Monopolies represent the opposite end of the spectrum from perfect competition. In a monopoly there is one firm that serves the entire market that has no close substitutes. Monopolies often conjure the image of a very large firm, but in reality a monopoly could be a small firm serving a small market, or it could be a large firm serving a large market. Unlike in perfect competition, there is no firm side and market side because the one firm is the entire market. This means that the market demand curve and the firm demand curve are the same thing. Unlike firms in perfect competition, a monopolist is not a price taker. They have the power to choose whatever price they want. However, they do have to contend with the law of demand. The more output a monopolist wants to sell, the lower the price is going to have to be. Essentially, the monopolist is choosing where along the demand curve it wants to be. So we could frame this entire discussion as either a choice of price or a choice of quantity. Ultimately, it will be the same. To keep things consistent with what we did over in perfect competition, which is entirely a quantity choice, we are going to frame the entire monopoly problem as a quantity choice. In perfect competition, we discussed the idea that in the long run, firms would enter the market if there's positive profit to be made, ultimately dropping the profit down to zero in the long run. That's not the case in monopolies. For monopolies to exist in the long run, there must be barriers to entry that prevent firms from entering the market. This can take a number of forms. From a practical standpoint, economies of scale can serve as an effective barrier to entry. Recall that economies of scale mean that long-run average total costs decline as output increases. If there's only one firm in the market, they're producing a large amount of output, keeping their average total costs low. If a second firm were to enter the market, we would enter into a duopoly, which we will talk about later on. The competition that would arise would lower the price and potentially make it not possible to make a profit with two firms. Knowing this, that second firm would never enter the market to begin with, and our monopoly would continue to exist. Legal barriers to entry are another reason monopolies can exist. A good example of this would be patents. Patents establish a legal monopoly for a limited amount of time. In the United States, the monopoly status granted by a patent lasts for 20 years from the filing of a typical utility patent. The patent system is designed to incentivize investment into research and development. By granting that limited monopoly status, an innovator is able to capture more of the benefits as profit from their innovation. Without patents, anybody could copy the innovation, making it much more difficult to profit off of innovating. That would lower the incentive to innovate. As with a firm in perfect competition, a monopolist has a profit, revenue minus cost. I'm going to write these as R of Q minus C of Q. Notice that I'm using a big Q this time because there is only one firm in the market, so there's never going to be a little q here in monopoly. Let's dig into the revenue function a little bit deeper. It's still price times quantity, but because a monopoly is not a price taker, the price is no longer taken as a given. It's now a function of the quantity. So R of Q equals P of Q times Q. P of Q is our inverse demand function. This tells us the price that a monopolist is able to charge given the quantity that they want to sell. Let's do an example. Suppose our demand function, QD of P, equals 100 minus P over 2. To find the inverse demand function, we need to simply take this equation and solve it for P instead of Q. Since we're making this into a function of Q, I'm just going to drop all of the notation around the Q and just write Q equals 100 minus P over 2 for the moment. Now we're going to solve this for P. I'll add P over 2 to both sides and subtract Q from both sides. And then multiply the entire thing by 2. That's going to give me P equals 200 minus 2Q. Be careful when you're doing this because a common mistake I see here is forgetting to multiply every single term by 2 or whatever number you have. To denote this is now our inverse demand function, I'm going to write P of Q over here. The revenue function, R of Q, is P of Q times Q. So for our example, R of Q equals 200 minus 2Q times Q, which will be 200Q minus 2Q squared. I find that multiplying these things out helps you avoid mistakes later on. To figure out how revenue changes as Q changes, we're going to find the marginal revenue, MR of Q. As with anything with the word marginal, we want to think about taking the derivative. So we're going to take the derivative of the revenue function. In our example, we have the derivative of 200Q is 200, and the derivative of negative 2Q squared is minus 4Q. Before moving on, I want to call attention to the relationship between our inverse demand function and our marginal revenue function. Notice that they have the same intercept, but the marginal revenue function has twice the slope. That is because of how the calculus worked here, where we used the power rule and we had a squared term. This is always going to be the case when we have a linear demand function. And in this class, we are going to be working only with linear demand functions from here on out. So if you want to use this shortcut of doubling the slope to get the marginal revenue, that's totally fine. But always remember to find the inverse demand function first. Doubling the slope of the regular demand function is not going to work. Now that we understand marginal revenue, we're ready to maximize the profit. So I'm going to write out the profit function again, R of Q minus C of Q. To maximize profit, we're going to take the derivative of the profit function. The derivative of the revenue is the marginal revenue, and the derivative of the cost function is the marginal cost. We set that equal to 0. This gives us our profit maximizing rule. The monopolist will produce the quantity where marginal revenue equals marginal cost. So we'll just solve this equation for Q. This is the same result that we got over in perfect competition, except that marginal revenue is now a function instead of just being the price. Let's illustrate this with an example. Let's suppose that we have a monopolist with a cost function C of Q equals 20Q plus Q squared. To get the marginal cost function, we're going to take the derivative of that. That's going to give us 20 plus 2Q. Using our profit maximizing rule, we're going to set our marginal revenue, which we found earlier, as 200 minus 4Q equal to 20 plus 2Q, and solve for Q. I'll subtract 20 from both sides to get 180, and add 4Q to both sides to get 6Q, and then divide both sides by 6 to get Q equals 30. I'm going to use a superscript M to denote the profit maximizing values for the monopolist. An alternative method to solving this is to set up our objective function, which is our profit, take the first order condition, and solve. That's exactly how we found our profit maximizing rule earlier, so we will get the same answer. To do this, set up the profit function, total revenue, which is price given by our inverse demand function, 200 minus 2Q, times Q, minus our total cost of 20Q plus Q squared. I'll just multiply everything out and clean this up a little bit, so we'll get 200Q minus 2Q squared minus 20Q minus Q squared, and then combine terms to get 180Q minus 3Q squared. To take the first order condition, we will take the derivative of the profit and set that equal to 0. So d pi dq equals 180 minus 6Q, set it equal to 0, and then solve. Notice that we have exactly the same equation as we did right here. I could add 6Q to both sides and get the exact same thing. Divide both sides by 6 to get QM equals 30. Either of these methods will be completely fine. There are advantages to doing both of these. The first method involves us getting the marginal cost and marginal revenue, which we might want to do anyway to graph things. But the second version is in line with what we're going to do later with some of our more complicated problems. Whichever method you choose, the next step is always to find the profit maximizing price. We use the inverse demand function to do that. Remember that the inverse demand function P of Q is 200 minus 2Q. We have a quantity of 30, meaning that our monopoly price is going to be 200 minus 2 times 30, which is going to be 140. Let's put all this information together onto a graph. As always, we're going to have quantity and price. First thing I'll do is sketch in our demand curve. Our inverse demand function is P of Q equals 200 minus 2Q. That tells us that our price intercept is 200, and our quantity intercept, 200 divided by 2, is 100. The marginal revenue function was the exact same thing as that, but with double the slope, meaning that it's going to have a quantity intercept of 50, but it's going to have the same price intercept of 200. While I often don't show this on the graph, the marginal revenue curve actually does continue into the negatives. In our example, that means if the firm produces more than 50 units, they're going to have to drop the price so much that the revenue is actually going to start going down. The marginal cost function in our example was 20 plus 2Q. Before drawing the marginal cost curve, let's note that our profit maximizing quantity is 30 and price is 140. To draw our marginal cost, we're going to have an intercept of 20 somewhere down there. We know that the profit maximizing quantity is 30, which is somewhere about here. So we know that's where our marginal cost curve is going to cross the marginal revenue curve. If we then find the quantity of 30 along our demand curve, that is going to tell us our profit maximizing price of 140. Finally, we are going to discuss the performance of a monopoly market, both from the firm's perspective for their profit and from society's perspective. For the firm, we're going to calculate our maximized profit, pi m, as revenue minus cost. In our example, we had a price of 140 and a quantity of 30, that'll be our revenue, minus total cost of 20Q of 30 plus Q squared, so 30 squared. Always be careful about distributing the negative signs properly here. Multiplying this out, we have a total revenue of 4,200 minus 600 minus 900. That's going to come out to a total profit of 2,700. This is positive, and this will persist in the long run because of barriers to entry. Next, we're going to think about social welfare. Recall that in perfect competition, equilibrium is efficient because marginal cost equals price. That is not the case in monopoly. At our profit maximizing quantity of 30, marginal cost is all the way down here, and price is all the way up here at 140. To calculate the marginal cost, we have 20 plus 2 times Q. So we have 20 plus 60 is 80. Monopolies always choose the quantity where marginal revenue equals marginal cost. But since marginal revenue is always below the price for any given quantity, marginal cost is always going to end up being below the price. As such, the monopolist is always going to stop short of the socially efficient quantity in the market. They're using their market power to pull back output, allowing them to increase the price and make a greater profit at the expense of society as a whole. The loss of surplus due to a monopoly's market power is called the deadweight loss. To calculate the deadweight loss, we need to see what is the amount of surplus that was lost due to producing less than the socially efficient quantity. So let's find the socially efficient quantity. Remember that that's going to happen where marginal cost equals the price, or where marginal cost crosses the demand curve. So we're going to set our marginal cost equal to our inverse demand and solve for Q. Marginal cost is 20 plus 2Q. Inverse demand is 200 minus 2Q in our example. I'm going to add 2Q to both sides to get 4Q, subtract 20 from both sides to get 180, and then divide both sides by 4 to get 45. I'm going to put a superscript SE for socially efficient. That's going to be just about right here, 45. For the socially efficient price, we can plug that 45 into either of our functions. I'll use the inverse demand. So PSE will be 200 minus 2 times 45, which is 110. So we can see that our monopoly is producing less than the socially efficient amount in order to raise the price above the socially efficient price to maximize their profit. These 15 transactions right here were lost due to market power. The deadweight loss due to this is going to be this triangle right here. I always find that drawing the graph helps to calculate the deadweight loss because it is a triangle. It is a triangle because marginal cost and demand are both straight lines, which they are always going to be in this class. I like to look at the deadweight loss triangle sideways. So the base is 140 minus 80. And the height is 15. We divide that by 2. This is going to come out to 60 times 15 over 2, which comes out to 450. In this video, we've introduced profit maximization for monopolies and the performance results both for the firm and society. In the next video, we will expand on our understanding of monopoly to monopolies with multiple plants.